Don't forget to subscribe and ring that bell.
Hey, if you were with me for free response question number 3, first of all, kudos. That was a very robust problem. A lot of figuring things out before we dove into the algebra. But we've got past that, and we're now on to free response question number 4, which I think will be a little bit more non-robust. I don't know. Well, we don't get a calculator, which is fine. I know some of you want to shed some tears, but we'll be okay. Let's dive into it. Free response question number 4. Unlike question 3, that only had an A, B, and C, question 4 has 4 parts, A, B, C, and D. And oh, I like the graph. It's just straight lines, and a g of x equals an integral of f. I mean, this is going to be much more pleasant, I think. Question 4 reads, let f be a continuous function defined on the closed interval from -4 to 6 inclusive. The graph of f, consisting of 4 line segments, is shown, well, to the left, not above. Let g be the function defined by g of x equals the integral from 0 to x of f of t dt. On what open intervals is the graph of g concave up? Give a reason for your answer. This is a real easy start, okay? I am thinking to myself that if g is concave up, I got to see where the second derivative of g is bigger than 0, or it's just positive. All right? So my first goal here is to find the second derivative of g. Let me move that little cursor out of the way. Now, if g of x is the integral from 0 to x of f of t dt, okay, and keep in mind, the graph on the left is f. So y equals f of x, okay? Or f of t, whatever. Y equals f. If I got to take the derivative of g, that means I got to take the derivative of this integral, which means g prime of x, okay? The integral and derivative kind of cancel, and this x goes into here. So the derivative of g is just f of x. This might come into play later. Who knows? However, let's get that cloud out of there. I need to find the second derivative. So I need to take the derivative of the first derivative. So now I've got g double prime. The second derivative is just the first derivative of f. This, okay, is going to be beautiful for us. Okay, so if I want to figure out where the second derivative of g is positive, I want to know where the first derivative is positive of f. And let's keep in mind, the first derivative of f is just the slope of f, where it's positive, which means where my graph is increasing. We have the graph of f. Oh, look at us go. Oh, hey, hey. All right. Well, it's increasing here. Okay. It is decreasing here. It is decreasing here. And it is increasing here. I see 2 intervals. All right. From -4, when x is -4, to when x is -2. From here to here. It's increasing. Also, from when x, oh my God. When x is 2 to when x is 6. All right, so let's do that. From -4 to -2, and from 2 to 6. Okay, but it says give a reason. Well, my reason is the slope of f, which is just g double prime of x, is positive. Indeed. these intervals. There you go. There's my answer. Those are the two intervals. Explain, what's your reason? Well, the slope of f, which is the second derivative of g, they're positive. The slope of f is positive in those two intervals. Done, good, that was great. All right, 4b is telling us, let p be the function defined by, okay, p of x is g of x times f of x. Find p prime of 3. All right, first thing is, I want to find the derivative of p first before I even think about plugging in a 3. I am multiplying two functions, so that screams product rule. So the derivative of p is the first, g of x, times the derivative of the second, f prime of x, plus the second, just as it is, f of x, times the derivative of the first, g prime of x. Now look it. A lot of people, when my son went to a different high school than I taught at. So he put this product first and listed this product second. That's fine because you can rotate around a plus sign. I just happen to do it this way. You should come up with the same answer, all right? As long as you have the products the same. Your g of x needs to be multiplied by f prime, and your f needs to multiply by g prime, okay? So let's establish that. Now, gacha, I'm going to put in my 3, all right? So I need p prime of 3. That's g of 3 times f prime of 3 plus f of 3 times g prime of 3. Here we go, here we go, here we go. Okay, the easiest thing that I can think of is f of 3. I have a graph right here. When I want to know what f of 3 is, I'm asking for a coordinate, okay? When x is 3, what's the y? All right, so let's go right here. When x is 3, it looks like to me that is a y of -3 in this coordinate. So -3, -3. So right here, we have our plus. This is -3. All right. Now, if you were here for 4a, we said something about the derivative of g. The derivative of g, let's just lower this for right now. The derivative of g is the same thing as f of x, okay? The derivative of g is basically f of x. So I'm going to go here. So this right here is like saying f of 3, okay? Which, hey, we just did that. We did it right here. We did it right here, kids. So times -3. So -3 times -3 is 9. So I've got the right side figured out. Let's look at the left side of my addition sign. Okay, these two. Okay, f prime of 3. That just means the slope of f at x equals 3. Well, we already looked on our graph at this point. This is where x equals 3. I need the slope of this line. Okay, I can take this coordinate and this coordinate. I can do change in y or change in x. Or I could just look at this line and see that it goes up 1 over 1, up 1 over 1, up 1 over 1. So it is rise up 1 over run over 1. The slope is 1. So this is going to be 1 times, all right, g of 3. Let's take a look at our original problem here. In order to find out what g is, I got to use this integral, okay? If I'm going to put a 3 here and find out what g of 3 is, I'm going to integrate from 0 to 3. This means area under the curve of f from 0 to 3. So let's go back to our graph here. 0 to 3. So I want the area under the curve from 0 to 3. All right? That's right here, right here. So the area under the curve here. I want this, since it's above the x-axis, will be considered positive. And these, because it is under the x-axis, will be considered negative. Okay, and we're going to combine those. And that is going to give us, okay, that is going to give us our area. First, let's do the easy thing. I think really the triangle that's highlighted in green will be easy. That is 1/2 base times height. 1/2 base height. My base is 1. My height is 4. Okay, 1/2 times 1 times 4. Half of 4 is 2. That is 2. Okay? So, to the top right here, the area under the curve is going to be 2. Okay? And I got to combine it with the area at the bottom. It looks to me like this triangle here is the exact same. It's 1/4. That will have an area of -2. Yeah, it still has an area of 2, but since it's below the x-axis, it's negative. So if I look at the top right, I have my +2 minus 2, and now I got to find the area of this kind of sliver right here. That is a trapezoid, okay? That is a trapezoid. And in order to do a trapezoid, it is 1/2, the sum of my bases, base 1 plus base 2 times the height, okay? So, base 1 is this side here. That is a distance of 3. Okay, I'm going to erase this. Base 2 is this distance here. That's 4. So it's 1/2, 4 plus 3 times the height. The height is this distance here, which is 1, which is my height, which is 1. Okay, 1 times anything is itself, so that's insignificant. 1/2 of 7, well, that's 3.5, 1/2 of 7. Since it's below the x-axis, we're going to consider that -3.5, that trapezoid area. So minus 3.5. Okay, these two will cancel, and g of 3, the area under the curve of f from 0 to 3, is -3.5. That was a little bit to do. It wasn't difficult. It was a little bit. 1 times a -3.5 is a -3.5. Now, if I have -3.5 and I add 9, I should get a positive 5.5. That's the answer to 4B. Not difficult. We just had to do 3 small shapes. Okay, when we're doing the area under the curve for G of 3, we have those 3 small shapes that we didn't or couldn't make a mistake on. We just had to be careful, find them all, combine them. Those that are under the x-axis need to be considered negative. Okay? I like this one. I like it a lot. Okay? So 4C, find the limit as x approaches 2 of g of x over x squared minus 2x. Well, as I always tell my kids, my super students, don't tell them I said that. I'm kidding. You can if you know any of them. And if you are one of them, work harder. No, I'm kidding. You're still good. You're a good kid. We are going to try to always plug the 2 in first for x and see if it works out. G of 2 over 2 squared minus 2 times another x, which is 2. Oh boy, we have an issue here. The bottom is going to be 4 minus 4, 0. G of 2, well, if you were here for 4b, from 0 to 2, this triangle has an area of 2. We just figured that out in 4b. This triangle has an area of 2, but it's below the x-axis, so it's -2. Okay? So if you're kind of just popping in, if I need to find g of 2, this is g. If I throw a 2 in for this x, I got to throw a 2 in for this x. The integration, or area under the curve, of f from 0 to 2. That's what I'm doing here. And notice, they're going to cancel each other out. +2 to -2. That's also going to be a 0. Whenever we try to do a limit and we get 0 over 0, we can use something called, oh my God, I hope I spell this right, L'Hopital's rule. Is there an E at the end? I don't think there is. I'm gonna leave that out. So those of you guys that are gonna correct me viciously here, I almost want to Google it. You know what? You know what? Oh my God, it's Jim Carrey. I used that in the intro. I'm gonna go here. Let's go here. And what a beautiful, that's my daughter in Hawaii. Just a wonderful time. Oh, look at that. L'Hopital's rule. There is no E. Why do I doubt myself? Because it's spelling a complicated word. It's not performing a complicated math problem. All right, L'Hopital's rule. What that tells me is if I end up with a 0 over 0, I can look at my original function. Now let's just do the x. I can look at my original function, take the derivative of the top and the bottom. Do not do the quotient rule. Do not do low, d high, high, d low. I am literally going to take the derivative of the top separately. And then I'm going to take the derivative of the bottom separately. Okay? So let's go ahead and do that. That would give me, well, the derivative of g is g prime of x. The derivative of x squared minus 2x is 2x minus 2. All right? And now I can try and throw that x value back in. All right? So I've got g prime of 2 all over 2 times 2 minus, oh, that's not an x, that's just a constant 2. Well, the denominator is 4 minus, oh, the denominator is not 0. The top. In 4a, we figured out that g prime of x was the same thing as f of x. We figured that out in part A. We used it again in part B, and guess what? We're going to use it again for part C. If I want to know what g prime of 2 is, well, that's like saying f of 2. Oh, my goodness. If I want f of 2, that's a coordinate. When x is 2, what's my y? When x is 2, the y is -4. So f of 2 is -4. Oh, wonderful. And what happens when I take -4 and divide it by 2? The answer is -2 all day long. All right. All right. This is the last part, 4D. Find the average rate of change. Shame on you if you don't know that average rate of change is just change in y over change in x, which is y2 minus y1 over x2 minus x1. Shame on me for making such a terrible y. But there you go. Find the average rate of change of g on the interval from -4 to 2. They have given us an x1 and an x2 already. So x2 is 2 minus my x1, which is -4. Now, how do I find the y values? I plug a 2 in for g minus plugging a -4 in for g. Kids, we've got 75% of this problem done already. What do I mean? Well, 2 minus a negative, that's like a plus, kids. So the bottom is 6, all right? We have done g of 2. We just did that in part C. Ooh, G of 2. Where is it? I lied. Where is it? Was it in part B? Was it in part A? Oh my God, G of 2. Oh man, I'm such a scumbag. No. Here we go. I feel like we've done it. It's probably there somewhere. I don't feel like searching for it. You know what? Just hit me. For L'Hopital's rule, G of 2 was 0. The area, the area from 0 to 2, this was positive 2, and this was negative 2. There we go. So we did do G of 2. That's 0. We have that already. This is 0 minus, we only have to figure out what G of negative 4 is. Okay? And let's keep in mind that G of negative 4, okay, well, we'll call this G of x, is taking the integration or area under the curve from 0 to x of the above graph, f of t dt. Okay, so if I'm going to throw a negative 4 in here, I put a negative 4 here. Okay, and the first thing I'm going to notice is the upper bound is smaller than the lower bound. So if I flip my bounds, I have to negate my integral. Okay, the area under the curve of the function. So now let's just find the area under the curve from negative 4 to 0. Well, there's negative 4, and here's 0 right there, where x is 0. So I want the area under the curve from here to here. Okay, I've got a triangle and a trapezoid. Okay, here's my trapezoid, and here's my triangle. Okay, this is 2 by 4. Okay, and the area of a triangle is 1/2 my base, which is 2, times my height, which is 4. Okay, that's going to be 4. This will be an area of 4. Okay, it's positive 4. So I'm going to come down here without negating it yet. I have 4, okay, plus the area of my trapezoid. Well, this is 3, base 1, base 2 is 4, and the height is 2. So it is 1/2 base 1, which is 3, plus base 2, which is 4, times the height, which is 2. Well, the 1/2 and the 2 cancel, and I just get 7. This area is 7. Okay? So, what do I feel like I'm missing? I feel like I'm missing something. Oh, I had 4 on the brain. This height isn't 4. That's a height of 6, which means, oh, Lordy, this value is not 4. That value is 6. Man, something didn't seem right. So this is 6. So right here, 1/2 of 12 is 6. This height, oh my God, this height is 4. That height is 6. Oh my God. That is going to be 4 plus 6. That's 10. The 1/2 and the 2 cancel, and it's 10. Wow. I'm going fast. So it is 6 and 10. So that's 16, but let's not forget, we got to negate it. It's negative 16. Whoo! That was a big mistake. Okay? So negative 16. Oh, and as a sidebar. Okay, as a sidebar, okay, G of negative 4, which I'm subtracting, is negative 16. As a sidebar, every once in a while I'll get someone say, you made a mistake. But once they make the mistake, they stop it and they type the comment, but they don't finish watching it. I had to reply to someone and said, yeah, you know, you're right. I did make a mistake, but I went back and caught it. It does happen from time to time. Okay, I am not perfect. Okay, I try to be, but you know what? Math is hard. If we can catch our mistakes, we learn from them and we become better. We become better at what we do. All right, so now back to here. And by the way, if I make a mistake and don't catch it, or even if I make it and then you type it, say, oh, but you caught it, that's good. That means you caught my mistake, which means you are getting better at it as well. I am not downplaying you catching me making a mistake at all. In fact, in my class, I used to give out candy for kids who would catch me making a mistake. But then some years I would hardly give out any candy. And some years I'd have to, I'd have to become Willy Wonka. It would be crazy. Back to the problem. When I subtract a negative, it's like adding. 0 plus 16 is 16 over 6. I mean, if you want to reduce it, you can. That would give you 8/3. So this answers the first question. Find the average rate of change for the interval from -4 to 2. Good. Does the mean value theorem guarantee a value C between -4 and 2 for which G prime of C is equal to this average rate of change? It is not asking you to find the C value, okay? It is not asking you to find the C value. The mean value theorem by definition says that if something is differentiable everywhere in an interval, then there's some point in between the interval that the derivative at that one point is equal to the average rate of change for my interval. We just found the average rate of change for the interval. So yes, the mean value theorem it's going to be equal. So why would they even ask us this? Look at my graph between 4 and 2, okay? Between 4 and 2, all right? Between 4 and 2, okay? Right here. Some people might say, oh, hey, it is not differentiable everywhere. Look at the corner and the cusp. Well, I guess that's 2 corners. Hold up. F, the graph of F is not differentiable everywhere from -4 to 2. But G absolutely is. I can find the area anywhere underneath that from -4 to 2. That's where the trick is. They're trying to get you to see that there's a corner there. So the mean value theorem only works if my interval from -4 to 2 is differentiable everywhere, meaning I can take the derivative everywhere. If you're looking at F, you most certainly cannot take the derivatives at these corners. But we are talking about the one, the only G, and that is differentiable everywhere. And yes, we can find the derivative of one point that's equal to that. All right? So I am just going to state, again, I'm going to state that, yes, the mean value theorem. Well, actually, let's do the explanation first. Since G prime of X equals F of T. And another way to look at this is, if we're looking at G, okay, and I just thought of this, maybe someone was kind of a little bit confused. We're looking at G, the derivative of G is F. It's not the slope of F, it's not the derivative of F. Between 2 and -4, there are points everywhere. There's no holes. There's no holes, which means this will always exist, which means this will always exist. I mean, there are so many ways to explain that, okay? But since G prime of X equals F of T and is defined, that's what I'm going to go with, is defined everywhere, F of T. I think that's an easier explanation to go with. It is continuous, is defined, and is differentiable. Because if it's differentiable, I can take the derivative of this everywhere. How come? Because this is defined everywhere. Because this is the derivative of this. I feel like I'm over-explaining it now. Okay, differentiable everywhere. Yep, there's a W. Between -4 inclusive and 2. So G prime of X would have to equal 8/3 somewhere. I mean, they're not asking you to find the C value where the derivative is actually equal to 8/3. There you go. Take a picture of that. Bring it to Walgreens, which is a local drugstore around here. You might not have Walgreens. Why don't you make a poster of it? I don't know, like a 3-foot by 2-foot poster. Frame it up nice. Spend $150 on a frame and hang it right in your dorm room. All right, we are done. Thank you. I will see you later for questions 5 and ultimately for the finale, question 6. See ya.
Don't forget to subscribe and ring that bell.